Look at this. The nuanced brushwork, the intricate play of light and shadow, the unmistakable emotional resonance. You might assume this masterpiece emerged from the heart and hands of a seasoned artist, someone who spent years honing their craft, pouring their very soul onto the canvas. But what if I told you no human being touched this piece? What if this entire artwork, every single stroke, every color choice, every inspired detail, was conceived and executed by nothing more than an algorithm? For centuries, art has been an intensely human endeavor. Even with the advent of digital tools, the Photoshop brushes, the 3D modeling software, the computer remained just that, a tool. A sophisticated paintbrush, perhaps, but still an extension of the artist's will. The human conceived the vision, then painstakingly translated it into pixels or polygons. The machine simply followed instructions. But that understanding, that fundamental division of labor between human artist and digital instrument, has been utterly transformed. The shift didn't happen overnight. It began with an explosion, an unfathomable deluge of digital data. Every photograph uploaded, every video shared, every painting scanned and digitized, an ocean of visual information. Humans could never hope to process, categorize, or even truly comprehend its full scope. This presented both a challenge and an irresistible opportunity. How could we make sense of this visual chaos? More importantly, could we teach machines not just to see, but to imagine new images from this overwhelming input? This question became the crucible for a new kind of artificial intelligence, one that didn't just analyze, but synthesized. To understand how AI truly learns to paint, we need to grasp its core engine. Imagine an ambitious art forger, obsessed with creating the perfect imitation, and a meticulous art critic, whose sole job is to spot fakes. This constant, adversarial dance is precisely how a generative adversarial network, or GAN, operates. The forger is the generator. Its job is to create new images from scratch, initially just noise. The critic is the discriminator. It's shown a mix of real images from a vast dataset and the generator's fakes. Its task is to correctly identify which is which. If the discriminator spots a fake, it tells the generator to try harder. If it's fooled, the generator gets a pat on the back. This isn't about human-like understanding. It's about statistical pattern matching on an unimaginable scale, honed by relentless competition. But generating convincing fakes is only part of the story. For AI to truly paint what we ask it to, it needs to see and understand the world in a structured way. This is where other powerful tools come in. Convolutional neural networks, or CNNs, are the AI's eyes. They process images by breaking them down into layers of visual features, identifying patterns like lines, colors, and textures, much like our brains identify basic shapes before assembling them into objects. Then there are variational autoencoders, VEs. Think of a VE as a librarian who can read every book in a massive library, then perfectly summarize each one into a single, concise paragraph, retaining all crucial information. It learns to compress complex visual ideas into a much simpler, yet information-rich, internal representation. When you type, "a cat riding a bicycle," other AI models connect your words to these compressed visual concepts, drawing upon countless examples of cat, bicycle, and riding to synthesize an entirely new image. The capabilities unlocked by these data-driven systems are staggering. Platforms like DALL-E 2 have captured public imagination by turning whimsical text prompts into stunning visual realities. But the impact stretches far beyond curious experiments. In the creative industries, generative AI is accelerating concept design, prototyping new fashion trends, and inspiring architects with novel structures. It's augmenting human creativity, not replacing it entirely, by quickly generating countless variations for artists to refine. And the systems are even used for highly specific, data-intensive tasks, creating hyper-realistic, yet synthetic, signatures for security system testing, or generating vast libraries of simulated materials for scientific research. The algorithmic canvas is painting not just art, but entirely new possibilities across industries. Yet, with such immense power come profound challenges. The same technology that can generate breathtaking art can also create hyper-realistic, deep fakes, spreading misinformation or even fabricating evidence with alarming authenticity. This raises critical ethical questions. Who is responsible when AI-generated content is misused? Who owns the output of an algorithm trained on countless human creations? As regulators worldwide, from the European Union's Digital Markets Act to emerging national frameworks, grapple with the implications, the art world itself is split. Some see collaboration, others see a threat to human ingenuity and livelihoods. The hidden incentives behind these complex systems, often driven by massive data acquisition, present a unique set of trade-offs that society is only just beginning to confront. We stand at a critical juncture. Generative AI is not a fleeting trend. It's a fundamental shift in how we create, perceive, and interact with visual information. Understanding that AI learns to paint not by gaining consciousness, but by mastering the patterns within colossal datasets, is crucial for navigating its trajectory. The coming years will demand careful consideration of its ethical implications, its economic impact, and how we choose to integrate such powerful tools into our lives. The algorithmic canvas continues to expand, redefining the very boundaries of creativity. The question now isn't just what AI will paint next, but what kind of world we will paint together with it.